We're going to look at factoring by solving equations. So we've done some of these before, and like I have said, I like to use a box to solve these. So if we're looking right here at number one, we've got x squared minus 9x plus 18. So I filled my box. I can put x squared here. I can fit 18 right here. So I get x and x. And two things that multiply to give me 18 that add up to negative 9. We've got 6 and 3. 2 and 9 don't do it, so it's got to be 6 and 3. And they both have to be negative because we want a negative times a negative gives me a positive, but a negative plus a negative gives me that negative. So we get negative 3x and negative 6x, which will add up to that negative 9x. So we're going to take those information on the outside and we are going to put them as x minus 3 and x minus 6. They equal 0. Notice that that 0 is there. So since they equal 0, we can set each one equal to it. X minus 3 equals 0 and x minus 6 equals 0. And then we just add them to the other side. So we've got, if we add 3 to both sides, we get x equals 3 and x equals 6 because we add the 6 to each side. Let's do one that looks a little bit different. If we're looking at number 4, we don't have 3 terms here, but they both have a b in common. So we're going to take out the greatest common factor. So we take out a b, and I'm left with b plus 5 equals 0. So I'm going to set each one equal to 0. B equals 0, and b plus 5 equals 0. Then we're going to just subtract b5 from both sides, and we get b equals negative 5. So we have two answers that I want to make sure I'm pointing out. We've got b equals 0. We've got b equals negative 5. Let's do one more. Let's look at 3, which is a special one where we've got two perfect squares. So we've got to remember that this is 9 minus 8. And 9 plus 8. And I simply took the perfect squares and square rooted both of them. But remember, it equals 0. So we have to solve this. We have to go n minus 8 equals 0, and n plus 8 equals 0. And we're going to then get n equals an 8 and n equals negative 8. Yeah. All right. Let's look at 6, though. 6 has that big number in front of our little square there. So we have to use something called factoring by grouping. So the first thing we do is multiply 15 and negative 4. That 15 and negative 4 is going to give us a negative 60. Okay? Then I'm going to think of all of the factors of negative 60, and this takes a really long time. So I am going to jump right to the one that works. We've got negative 6 and positive 10. And they add up to be, you got it, positive 4. But I might take me a minute to list all of those. So be aware of that. Then I'm going to rewrite this. I've got 15b squared plus 10b minus 6b minus 4. Okay, equals 0. Then I'm going to take the greatest common factor. So I'm going to take those certain ones together. I'm going to put 15b and 6b together because they are both multiples of 3. So I'm going to go 15b squared, b squared minus 6b plus 10b minus 4 equals 0. Okay, and then I am going to take out the greatest common factor. So 15b squared minus 6b, I'm going to take out a 3b. And I'm going to be left with 5b minus 2. And then out of 10b and negative 4, I'm going to take out a 2. So I'm going to have plus 2, and I'm going to get what I want, which is the exact same in the other one, 5b minus 2. So see how both things in parentheses are the same? That's what we want. And then we've got 3b plus 2, and that is multiplied by the 5b minus 2. And that equals 0. So then I'm going to set each one equal to 0. I've got 3b plus 2 equals 0, and 5b minus 2 equals 0. Now, this is going to take an extra step. We're going to have to subtract the 2 from both sides, so I get 3b equals negative 2. And then I have to divide by 3, so I get b equals negative 2 thirds. Okay? And then I've got to do the same thing with the other side. I've got to add 2 to both sides, so I get 5b equals 2. And then I've got to divide by 5 from each side. So I get b equals 2 divided by 5. And you can just leave it as the fractions right there. Those are your answers. Those are your y-intercepts. Those are where, excuse me, not y-intercepts, x-intercepts. They're your solutions, your roots. So that is my answer and how we do a bunch of different of these factoring. Some by grouping, some by taking out the greatest common factor, some by special occurrence, and a lot of them by just the box method.